If you remember, when we did the commercial project load calculation, we calculated the neutral. This time, I did calculate the neutral slightly different. I'm going to show you where I had the neutral. Slightly different. So let me just orient you through this sheet. Here's the stuff that you're supposed to do. And please give me a thumbs up if everybody understands what we're doing. From one calculation, you need to size the switch gear. The switch gear is the main panel for the building. Thumbs up, Chad. Everybody knows. Main panel for the building called switch gear. Next, receptacle panel. All the receptacles inside your building will be fit from one standalone panel. Thumbs up, Chad, for that one, receptacle panel. 2, lighting panel. All your lighting loads in the whole building, upper and lower, will be fit from one standalone building. Thumbs up. You guys are start auto here. Okay, mechanical 1 and mechanical 2. Now I want your full undivided attention. MP1 and MP2, that's mechanical 1 and mechanical 2. The way we want to design the system here, Joe, if I have your attention for 1 second. Yeah, mechanical 1, it's going to be a mechanical panel in the first floor. Any mechanical equipment in the first floor will be fit from the mechanical panel first one. Any mechanical equipment in the second floor or the roof, the second floor or the roof, will be fit from mechanical panel number 2. Can I have thumbs up, Chad? We understand how we're going to do it? Because you have to make a decision with what's going to be fit from what. Okay, then busway 480 busway. All the equipment that's going to be fit from that 480 is going to be fit from a bus that's called 480. You guys remember what we did yesterday when I showed you the mechanical equipment, the owner equipment list? Anything that says 480 is going to count right in under that bus. Okay, 480. Right next to it, any owner equipment that says 208 is going to be fit from where? From a 208. So what the heck is that, Chad? This is a big fat bus coming from a panel and feeding all the 208 owner equipment stuff. Can I have thumbs up, Chad? We understand that?
Is that the busway that is more just for sizing wires?
Yes. Yes. It's not a panel. It's a busway. And I'll show you how to size it. This is just to size the feeder that's going to feed it. Good point. UPS. We have a UPS system in this building, guys. You're supposed to design a UPS for this building. So the UPS is going to be the computer load. Only the computer load that's going to be fit from the UPS. I'll show you in a second. PDUs. The way we design the UPS and PDUs, there will be 2 PDUs fit from one UPS. That's how we do it, redundancy. So 2 PDUs fit from one UPS. So the UPS and the PDU, for the most part, almost they're going to be the same size. The same size.
So should there be 2 PDUs or just the one?
The way we're designing the system right now, 2 PDUs. Typically, what's a PDU? PDU is a panel. A PDU is a panel. It's a panel with typically a transformer inside it. A panel and a transformer, they call them power distribution units. The way they design data centers, guys, they take a big fat UPS here and they feed PDU1 from it, and another big fat UPS2, and they feed the PDU2 from it. For us, if you look at the project, we only have one UPS, because the building is small, and we're feeding 2 panels from it. But the 2 panels are going to be carrying the same load. So for redundancy, so if the panel was a 300 amp, it's going to be 300. So that's why we size only one of them. Cool?
So all of it goes to the one, it's just there's 2 of them that are the same.
Yes, for redundancy. Good point. That's one my PDU and UPS. The last one is emergency panel. Like, what's his name? Guy, thank you. So many people. Like Guy said yesterday, this building is going to have an emergency panel building. So we're going to put the emergency load in the panel. We're going to call it emergency load. Light and exit signs. Cool? Everybody understand what's at the top that need to be sized before I move on?
Can we divide the mechanical panel into the equipment list and the owner list?
Mechanical panels are strictly, okay, that's a good, very good point. Let me show you something. If you don't mind me showing you one little thing, will you? the loads, you need to understand how the loads are related. I'm going to go directly into this load. Yes, Chad. Okay. Okay, here's the, yes. Oh, come on, open it. Doesn't want to do that for me. You have two sets of mechanical equipment. One mechanical equipment to heat and cool and ventilate the building. These are where mechanical 1 and mechanical 2 are related. M1 and M2 strictly for heating, cooling, and ventilation of the building. You guys understand? Which is basically this list. This list of equipment. This is the list that for M1 and M2, you're going to be size M1 and M2 based on this. For the bus 1, 208, and bus 2, 480, you're going to size them strictly based on the information here. These are owner equipment. These are owner equipment. Have I made the distinction between owner equipment and mechanical equipment? Mechanical equipment strictly for cooling, heating, and ventilation of the building. This is this list at the top. Right here. So when you size M1 mechanical, MP1 and MP2 is going to be sized based on these. Bus ducts are going to be sized based on this owner equipment. Very, very strictly important to know that. Cool? Make sense?
So the bus ducts is just the owner equipment?
Just the owner equipment.
Okay.
Strictly. Now, why are we doing it?
It's all manufacturing floor.
Yes.
So that's all going to be first floor.
Yes. I don't think, yeah. Yep, absolutely. And it's going to be fit from bus ducts. It's going to be fit from bus ducts. Okay? Any questions about this? Very important to know that. Okay, so we got that. All right. So these are what we need to size. Now let's go for sizing it. Do me a favor before we change the receptacle, single receptacle. The number, use the number of receptacle that we have right now because we have no idea how many receptacles. Use these numbers. Are my numbers match your numbers right now?
From the previous one?
No. From the sheet that you have on the network.
Yeah.
Okay. Do me a favor. The only thing I would like you to change, guys, here, they're multiplying. Remember that was 90. Change this one to 360, will you? So this will be 80 of them multiplied by 360. Can you guys change that one to 360? Because these are quads. The quads, each one single receptacle in the quad count is 80. 80 times 4, they'll give you 360. So that number has to be multiplied by 360. Okay?
90 times 4.
90, thank you. 90 times 4.
You can't just put it on. Okay.
Or whatever you...
Yeah, we just have the times 4.
Not a biggie. Not a biggie. Account for it, though. Everybody's there? So that's your receptacle. Right underneath it, these are 5-foot and single-foot sections, guys. Use these numbers, 96 feet and 50 feet simultaneously used. These are the mold that we're going to be using in the lab. The mold that we're going to be using in the lab. So you're going to come back and measure them again, verify. Remember in the lab, on the second floor, there's a mold, basically power plugs that could be feeding the lab with both sides of the lab. These are the mold, simultaneously multi-out assembly. Okay? Then, the next step is, were you saying that the codes are not right? So 220.14i is not right?
That one's right.
Okay.
The one that printed off wasn't right. Because it's a 2...
This
220 dot,
Yeah, see, ours on the bottom says 220.3B9.
so yours is different than that one.
Yeah.
Okay. Let me PDF this for you. Okay. Can I PDF this for you guys? Let me PDF this for you in a second. I'll PDF this for you. Cool. Okay. But before, so that will get you the. So then, you take the. They take the first 10,000 square. The first 10,000 K. You apply them 100%, the remainder at 50. Everybody understand what we did? We added all the receptacles. We applied the demand factor for them. And this number, can you guys see that? So number of receptacles times 180, get this here, number of receptacles, quads, multiplied by 360, get you this number, add them up. Number of multi-out assembly, multiplied by 180, non-simultaneously used, simultaneously used. add them up, add the total here, and here's the total, and then you apply the demand factor, Jeff. You apply the demand factor for them, and that's the number. 34.5 kVA is the number for all your receptacles. I need thumbs up, chat, for my receptacles. This is typically what you guys did with me in the commercial project. Okay. Now, here's my question for you, Adam. Now, this is the load for the receptacles. Now, do you guys agree with me? The load for receptacle will be seen by the main switchgear, right? Because that's the main switchgear is going to see everything. And also by which panel? The receptacle panel. Why do you think the receptacle panel is going to be feeding receptacles? Because it's called receptacle panel, right? Everybody understand why these two numbers are under RP and SG switchgear only? Can I put this number under LP? No, it's not going to be fit from a lighting panel. How about MP1? No. Am I the only one who's excited here? Okay, I need thumbs up that we understand fully, Chad, where this number came and why it's under these two columns only.
Are we gonna have any future growth? Like we did last year?
Way at the bottom. Way at the bottom. Yeah, there's 25% at the bottom. Cool? That's your receptacle panel. Let's go to another system. Now, that's I have unknown receptacles here. We did not do anything with it. Data. Do you guys have the data loads? 645.25. Is yours show that? Or maybe mine is updated differently. Yes? Data loads. Everybody can see the data loads. We have. Okay, I'll PDF it. Gentlemen, we do have a PDF. We have a data center in this building.
Well, that's special rules.
Yes, a data center, unknown as a data. I call it data center.
4.1 on this one.
Yeah, I will email you guys the. I'll email you this one. I'll not email you. I will upload it in a second. I really will. PDF. Now this load, but before I go there, this is Kerry. Here's the square foot of the data center that we have. Everybody can see the square feet of the data center right here. Multiplied by 100 actually should be 150. You remember how we changed it yesterday to 150? 150. Okay. So that's multiplied. Where is the 150 coming? Design criteria for the data center is 150. Multiplied by efficiency 1.1. Because the system has losses in it, and because it's also watt versus amp, I up it 10%. That's what I'm doing. I just up it this 10% to accommodate for efficiency and for the most part power factor. Everybody understand? This is Chad Curtis factor. Okay? And then you multiply it by 125%. Why 125%? Continuous load. So I'm really upping it a lot if you look. And this is the total for the data center. And Jeff, the total for the data center is going to be right in here. It's almost 374 kVA. Now, here's my A student is going to tell me. It's going to be seen by the switch gear here. And where else it's going to be seen? And PDU, thank you. And this will be fed from UPS, gentlemen, and the PDU. See how easy that is? Even my grandma would do that. Any question, guys, about this?
We should use your square footage then? Is that
For the time being, yes. For the time being. Later on, you guys are going to go measure the area and verify it. You're going to measure the area and verify it. Any question about the data load? I will PDF this one in a second for you. Any question about that? Okay, let's go to the next one. And you can see how this cell is. Everybody knows how the cell carries is, the math. Just equal. Can you see that? It's not rocket science. Really. And this calculation, how this calculation is, this is just a product of all these numbers. Okay? Okay, so we got the data center. Let's go down. Before I move from item data load number 5 into number 6, owner equipment. Any question, guys, about item number 5 in my sheet, data center? Any question about that? So lighting, receptacles, and data is done. Let's go to owner equipment. Now, Kerry, my friend, owner equipment is the bus duct. That's what we call it, owner equipment. Can you guys see the stuff right here? Everybody can see that?
Lighting this time?
No, we haven't done lighting yet.
Okay.
It's underneath. It's coming. This is the owner equipment list. Now, these are all coming from the list that we were looking at right here in a second. Can you guys see that? This is coming from this list. Here you go. This is the same list that you're looking at, right? Okay. Cool, Chad. Let's go here. Now, I want to remind you of two things here. Number one, there are certain things here that's 208 and certain things that some is 208 and some is
There's a couple that are 208/120. You just use the.
not a biggie. If it's 208/123 phase, doesn't matter. If it's 28 only, no single phase, then you multiply it by 28. I'll show you an example. Let's look at the tube mill, guys. Tube mill. I have 12 of them, right? The KVA is 4.68. How did you find the 4.68? The tube mill, let's go look at the tube mill. What is the tube mill? Right here. The tube mill, gentlemen, is right here. What can you guys see the voltage here? So this is coming from taking the voltage here, which is 208, multiplying it by the current. So this is equal, here's how this equal this multiplied by, where's multiplied? Multiplied by the voltage, multiplied by the current, right? And then there's 1.73. Why do you think 1.73 is there, gentlemen? 1.73 divided by 1,000, because in KVA, 1,000. So that's where the 4 and approximated, of course. Oops, this way. Okay, this is the 4.7. Did we came with 4.7 guys here? 4.68. Okay, right here. Everybody understand where the 4.68 came to be? Everybody understand where the 4.68 came to be? Cool? You take the voltage, multiply it by the current, divide it by 1,000. Okay?
But it gives us amps, so we don't use the amps.
You use the amps. You use the amps. In that 4.68 is already showing the amps in it. Here, let me show you how I did it here. If you look here, see where the amps came to be? Let me click on this. Can you see where this took the voltage multiplied by the amps?
Okay, I see that you have the same KVA total that I have. I guess I'm not sure. I guess I wasn't paying attention to what the individual one was.
Oh, the individual one is take the voltage multiplied by the current.
Multiply that number by 12 and then get it. Okay.
Yes.
I didn't do the individual, I just did it.
You lump sum them all? Okay, gotcha. Okay, but everybody knows where these numbers came to be? These numbers came to be. You take the voltage, multiply by the current, divided by 1,000. If it's 208, you multiply by 208. If it's 480, you multiply by 480. If it's three phase, you multiply by 1.73. If it's not three phase, what do? You only multiply by 208. Or
Well, you doing a continuous level 1.25 by the design factor 0.8, doesn't that just cancel each other out?
you got it. You absolutely got it. These are machines, can run continuously. This is, the stuff here is Chad Curley's opinion. So if you go to your boss and say this is horseshit, you just take it away. Okay, that's an opinion. Because these are machines, guys, are continuously running, I'm going to up them 25%. But because there's so many of them, it's highly unlikely that you're using all the welders and all the tube mills and all this stuff simultaneously at the same time. So there's a diversity factor. And that 0.8 is your friend Chad Curley's demand factor or diversity factor. So really, in reality, as if we just lump sum, add them up. Because but I want you to be aware of the demand factor, which is diversity factor, as well as the continuous load.
The NEC code said that we're just supposed to take them all and then we just multiply the largest one by 1.25.
These for motors.
Right.
Motors, we're going to do that for motors.
Okay.
Absolutely.
The order equipment's going to be separate than
Machines. Well, what is the difference? Yeah, that's why. Take it from Chad, add them up. Yeah. Even if you take 25% on the largest, at that size, it wouldn't make even a difference. really. The size is so big. Yeah. So, but that's the idea here. Therein, the idea is they're continuous load and they have a diversity factor. Continuous load diversity factor. Any comments, any questions, guys, where we got them? I want to remind you why the red, do you guys see where the red numbers here? I think the red are 480, if I remember right. Let's say the extruder, yep. Yeah, anything red is 480. Anything red is 480. So why would you think your friend Chad care if it's 480?
480 bus lanes.
Yes, there are two types of buses. One 480. So all these, can you guys see these? All the 480, to make it easier for you to transfer them, we put them in red. You understand? Everybody understand why they're red? So here's the 480. If you come over here, my friend, so the extruder, the baking oven, cutter, grinder, and welder, or welders, or cutters, all these are, my friend, all these are 480. Okay. Any question, guys, about how we did the math? Kerry, does it make sense how we did the math? Andrew? Darren? Huh? Yeah. Yeah. I would like you guys to show the efficiency and the factor though.
You want the efficiency.
Yeah, because so you know that there is something called efficiency and continuous load somehow. Okay, then Jeff, here's what we did, my friend. Then we added them all up. This is just adding them all up. Can you guys see that? This is adding them all up. And then there is almost 915 kVA, 915 kVA here under the switchgear. They're all going to be seen under the switchgear. Everybody can see it? And then, come on, under the switchgear, under the buses, look what happened. Under the 480, let me show you why my math for 480, so you guys can do the math. Look at 480. Under 480, here's the stuff that I'm carrying under 480. 1, 2, 3, 4. And do you remember what these are? These are the 480 loads. Does that make sense? Oops. Here you go. So the 480 are the red ones. Everybody got that one? Otherwise, it's going to confuse you guys. There are two. These are the own equipment, but there are two buses. One 480, one 208. The 480 is going to be under the 480. The 208 is going to be under the 208. But Jeff, when they're seen by the main panel, all of them are going to be seen by the main panel, right? So under the main panel, they're all added up, all of them. Under the buses, they're split into their own bus. Kerry, does it make sense? How we split them?
We're already putting down the voltage down already, so it was already one of our lines.
Okay, so depending how you do it, but do you see the two values here though? Do you see the two values? Why are they there? Any question about the owner equipment? That's how we do the owner equipment. Shall we jump to the next step? Mechanical equipment. Everybody's, Brian, makes sense? Yes? Zach? Okay. Jamie? Okay. Let's go to the next. Next stuff is going to be general lighting. Here's for general lighting. For general lighting, guys, I have general lighting. I have two ways. I have the code. Now, this is Chad Kirdy's assumption. You're going to compare two values. 3.5, assuming this is like an office building, applying the rules of an office building. I know not all of it is an office. There's a lot of labs and blah, 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 but we're not going to split hair here. We're going to slam it, all of it, treat it as an office building. It's a manufacturing plant. Office building will cover manufacturing and everything else in terms of light. And I'm throwing 3.5 from the code, multiplied by the square foot of the upper and lower floor. Can you guys see that? That 24, almost 24,000. Get you this number. And why is 1.25 again? Continuous load. Okay. Then I have all my fixtures. Can you guys see all the fixtures? I want you to type them as is. You guys have not done your fixtures yet. When you design your fixture, this is the volt amp is going to come. These are for your fixtures. Fixture A, 155 volt amp, 34 of them multiplied by 1.25, get you this, and you keep adding them. The actual load. So you take the 3.5 and the actual load. And what do you do when you have two numbers? Which number are you going to pick? The largest. And that's what we did. So for this, where am I here? So I get this is 104. Can you guys see that 104? That's from the code, and I put the 104 under lighting. Why do you think went under lighting? Because it's lighting load under lighting. And the actual load, can you guys see the actual load happened to be much less, 1, 2, 3, like 61. The actual load is 61, and the calculated load is 104. Everybody knows why I picked this number here? Max. Do you see what the max is? Here's what the function is. The max, take this number here, everybody can see that, and this number, and take the max of the two. I need thumbs up before I move, or I'm going to sit here and dwell forever. So you add the two numbers, guys, and you take the max of them. That's what we did, this number. Okay, and since this is lighting, Adam, lighting is going to be fed by the switchgear as well as the lighting panel, right? So I just put it under the lighting panel. Do you put it under any other places? No. It's not going to be seen by the mechanical equipment or bus or UPS. Can I move away from lighting? May I move away from lighting?
Do we have any signs or anything like that?
Well, we're coming here in a second. Then I have general lighting. Okay, we did that. We have attract lights. I have attract lights. I'm using attract lights. Now remember, we might not have attract lights, but please design it. I have attract lights of 50 and a sign of 120 and a show window of, I don't have a show window here. All these are all my lights, and I'm picking them right here and putting them under the main panel as well as the lighting panel, under main and lighting panel.
Is there any lighting that's not continuous?
No, not in a commercial building.
Can we total all the different lighting and then add the multiplier? over
Yes.
to that?
Yes. Yes. Absolutely. Yes.
I wonder if I had to change it one way.
No, no. You account for the 1.25 at any point of the system. Okay? So this is where these coming from. Any up to 11, guys, all lights. Any question up to 11? Let's go to the kitchen equipment. I put a 20 amp circuit for kitchen equipment here that give me 24. That's for whatever is there. Just a little bit of 24, not a whole lot. Then I move into non-coincidental loads. Non-coincidental loads, guys, these are the heating and the cooling. The heating and the cooling.
So you just hit one.
Just one load, one little load. Now heating and cooling. Look at this. My heating, the only thing I have heating is what? Boiler circuit, which is peanuts. And in terms of air conditioning, I have two chillers. Do I have, right? I have chiller and cooling tower. I have my chiller and my cooling tower, right? My chiller and my cooling tower, these are part of my cooling system. Everybody can see that? Chiller 1, cooling tower 1. Here's the information about them. And then you compare the heat and the cool, and guess what you're going to get higher? Yep. Everybody can see that? Gentlemen, everybody can see that, Joe, my friend? Okay, and this is where the 579,000, okay, now, this one will be under the switchgear and also under where? Oops, I didn't carry it. Hold your horses. These are fed directly from the switchgear. Why? The sheets. Go back to the project as requirement. I thought they asked us to feed them. These two are fed directly from the switchgear. That's why. Power criteria. Yeah, chiller. If you guys go to item 1.4 here, it will tell you that your chiller is going to be fed directly from, my chiller is going to be fed directly from the, my chiller is going to, from the switchgear. My chiller is going to be fed directly from the switchgear. Directly from the switchgear. And it seems we are feeding also the cooling tower from the switchgear. The chiller and the cooling tower, we decided to feed them from a switchgear only. Any questions about that? Yes, no? Too much? Okay. Then we go to the mechanical equipment. Mechanical equipment, guys, I have red and black. the red ones are fed from the, I believe, from mechanical panel number 2, and the black ones are fed from mechanical number 1.
So you're letting us know which ones should be above.
Yes.
Upper floor and lower floor.
Yeah, 2 is going to be upper floor. Exhaust fans are in the ceiling. All of them are in the M2. Air handling unit 1, 2, and 3, right, supply and return, they're going to be in the second floor. So the red ones are fed from mechanical panel number 2. The black ones here are fed from mechanical panel number 1. Okay? Same thing. Here's what you do. You guys see, you take the full load amp, multiply by 1.73, 480. This is where you take the largest, fattest, fluffiest motor. Can you guys see this is the largest of all of this? The largest of all of this, and you add 25% on the largest. Add them up. You put them on the switch gear. This one here, I don't know if you guys can see. These are for the, this is for mechanical panel 1. And this one here is for mechanical panel 2. This one is for mechanical panel 2. Everybody understand why it's red? Because some of them are going to be under mechanical 1, others under mechanical number 2. I need thumbs up. Okay. See how easy that is? Piece of cake. The info is there for you. The numbers for the most part are right. Please verify them though. Please verify them. Verify the numbers. Okay. So that's my mechanical equipment. The last thing, guys, is here's what we did then. We add them up. Can you guys see the volt amp way at the end? Total volt amp here. I added all my volt amp under the switch gear. I came up with 1, 2, 3, 4, 5, 6, 2.5, almost 2.5 mega volt amp. Can you guys see that? That's a lot of volt amps, right? Do you see the mean? That's the size of your switch gear. Now, look what happened. If you click on this cell to give you what I did, I just copied everything in this column. I added all these things in this column. Can you guys see that? Then underneath it, look what happened, the 3,000. Then you took this number, divided by 480, 1.73, that will get you the amps. Piece of cake, Chad. So here's where my 3,000 here is coming from taking, can you guys see that? Taking this number, dividing it by 480, 1.73. I need thumbs up, Chad. Cool. Then, hold on a second. Then, can you guys see where add, here's what the formula is, minimum. You guys have these like I do? Do you have the formulas at the bottom? In the sheet that I gave you. Does it have the formulas? Okay, future expansion. You ask, who asked about the future expansion? 25%. Here's my future expansion. I took my future expansion, I added 25%. Here's what that. Can you guys see there? And you see where it says 25% to the top? Then I went to DeWalt. Under the sheet that give you the size of the panels and switch gear, and I dropped how much size? 4,000 amp switch gear. Everybody can see that? 4,000 amp switch gear. Underneath it, I size my cables to match the 4,000. Then underneath it, I size my neutral. Here's how I size my neutral though. My neutral, if you read here, the way I size my neutral, guys, you take the first 200 amp. Remember how we did it? Leave them alone. Anything higher than 200 amp, what do? Cut them by 70%, add them up, and size your neutral. That's how the neutral size. All this is said right here. Then underneath it, the grounding electrode conductor, I size my grounding electrode conductor, and I size my conduit. That's for the switch gear. What I'm going to do, guys, I'm going to get rid of my sizes and give it to you without the sizing. So you can do the sizing yourselves. Then the same thing under the receptacle panel, Jeff. Here's my load. The same thing, add 25 on it. I end up with 150 amp panel. Lighting panel 129, add 25% on it, 169. I end up with 175 panel. What's that? This is the mechanical one. My mechanical one, guys, I end up with 300 amp panel, 600 amp panel for their baby. Busway 1 and 2, same thing. You take this number, divide it. Can you guys see? Divide by 480. 991. You go to DeWalt. You go to DeWalt, and that's where you size the busway. They tell you that there is a 1,000 amp busway.
We're just on the busway, we're not actually putting it out.
No, it's just a busway. And if you guys go here, in page 3-12 and 313, the busway sizes and the panel sizes are right there. So you size it like we did in the commercial project. The same thing for the 208. I end up with also 1,000 amp for the 208. Then the last two things that might confuse you guys, UPS and PDUs. The UPS and PDUs, we size them based on KVA. So here's the size that I came up with right here. Right now, the size larger than what I have. So I will go look at the size here. I'm going to go right here because I change it into 500 KVA.
That's including the 25%.
Yep, it's already included right here. 500 KVA.
Round it up.
Yep, and then I'm going to go to put 500 here. The reason why my numbers are different than yours guys, because remember we changed it a second ago. 500. Okay, so I end up with this amps. The PDUs and the UPSs are sized based on KVA. The reason why I need the amps though, because I need to size the cables. I need to size the cables. When I get the amps, then you can size the cables based on this value. Later on, so these are probably the least experience that you guys have, UPS and PDUs. Just use my numbers for the time being, and I'm interested in the KVA, and then I have tons of calculation we're going to be doing about UPS and PDU sizing. I know we haven't done that. Emergency panel. The emergency panel, can you guys do me a favor for the emergency panel? At least put yourself, let's put 125 amp panel. Put 125 amp panel until we size it, okay? Because we need to drop a panel. Can you guys put 125 amp panel emergency, because we don't have the load yet on the emergency. Throw 125 amp for the emergency load. Later on, what we're going to do, we're going to add all the volt amp of all the lighting emergency lights and size them, and I guarantee you probably we will get less than 125. Remember, these panels are 480-277 guys. The lighting panel is a 480-277 panel. The only 208-120 panel is the receptacle panel and the bus duct, which is 208. That's why the amps is small, Jeff, because the voltage is high. Any question, guys, about the load calculation? Does it make sense? Okay. Now, I think the version that you guys have is different than the version that I do, right? So here's what I'm going to do. I'm going to PDF this sucker, put it on the network for you, and I would like you really to verify and understand it though. Verify, understand all the numbers, and build the system in a format similar to this. Later on, Jeff, you're going to come over here and all these fixtures, it's going to be different. Your fixtures are different than my fixtures here. Okay? Any question, guys? Is this enough to get you to build this riser?
So then we don't need the extra column for the neutral.
We don't need the extra column for the match.
The mechanical panel.
Yeah. By the way, how did we size the neutral? Very good point. How did we size the neutral, Chad? If you go down at the bottom, the way I size the neutral, guys, right in here, if it's, I think I put 300, yeah. If it's 300 amp or less, full neutral, receptacles and lighting. More than 300 amp, we start applying the rule of 200, leave them alone. Higher than 200, cut by 70%. That's a rule that we apply for the neutral. And instead of adding the neutral current like we did detailed, you still can't do that. I mean, either way will work. But we did it in the commercial project. We have an item for the neutral. The project becomes bigger. Like you can see, there's so many other panels. We're interested in the bigger picture. And when you get higher amps, guys, the neutral becomes not a big of a deal. Okay? The last thing, guys, grounding conductor, equipment grounding conductor, or grounding electrode conductor here. These are two tables you're using. You're using 250.66, and this is also written in it, or 250.122. Other than the service, other than the service, everything is going to be 250.122. Other than the service. The service is the only one that's going to have 250.66. Also written in that one. Any comments, my friends? Any questions? Any comments, any questions? I want to remind you, the sizes are wrong here when I PDF it. My sizes are wrong for one reason, because we changed the project. So I'm going to just email you to give you the format. Then you have to go check the sizes. These sizes, I guarantee you, are wrong. Some of them. At least 40% of them are wrong. The sizes here. Please verify them. Cool? Any comments, guys? Any question? I just want to make sure that when you're with my friend Ryman tomorrow, you are in good hands with all states. Okay? Any comments about the load calculation? Any question? Yeah. There's
And are all your code references right too?
the code references should be right. Yeah. I think the one that we did was from an older version. I used to throw it to students so you can verify it, but you guys have verified them in the commercial anyway. So I'll PDF this one, put it in the network for you. That's how I would like you guys to build the same, if not similar. What I don't want you guys to do is I don't want you to exclude the material here. I want to see them somewhere in the calculation. Does that make sense? Everything here, I need to see it. How you format it carries up to you. How you format it is up to you.
I have my actual writing on a sheet 2. Is that fine? It doesn't have to actually be in the line.
And the sheet 2, and when you print them together. And it's linked. That's fine. So when you save it, it will be like it will be tab 1 and tab 2 linked together. That's fine. Yeah. So what my friend is saying is, instead of putting that one right here, can I take this and put it in a standalone sheet, link them together? Be my guest. Yeah. I like to do it this way, guys, because one location, one spot, I can see the big picture. Can you see? Just by looking at one single sheet, I can see everything that I want. There's something to be said about having multiple tabs and linking tabs together, but whatever you prefer. You can take this sheet, Kerry, right now and use it for any project that you have. It really is similar. So if you came up with anything less than 4,000 amp for the switchgear, you did something wrong. The switchgear will be 4,000 amp, the main. The rest are going to be slightly different, but the main is going to be 4,000 amp. Done. Okay, is this enough, guys, to get you running with the load calculation? Yes? Okay. Let me give you 10 minutes, and I'm going to just mention one more thing about the, what do you call that thing? Microsoft project. One thing about Microsoft project, I'll let you work on your stuff. Are you guys going out to eat? Not yet? Okay. Give me 10 minutes. All right.